sphere. Is it working? Yeah, you see it? Okay, seems working. All right, let's get started. So I here will try to introduce to all of you about this computational engineering project course. Have you got any idea about it? Did you hear anything from most likely people before, 1 year earlier than you?
Something was mentioned in the material science.
Exactly.
I remember some parts of those.
Yeah,
Some information.
exactly. Good.
I think my advice mention this that I would be doing.
All right. Who's your advisor? Look. Yeah. Perfect. Well, good. So this is I think this is a compulsory course for all of you. And the purpose of it will be explained later, but as you can see, the key point is about the project. I mean, you're all majored in computational engineering, and now you have learned a lot, yeah. And the point of this course is really to do a project. So by project, I really mean a project. And it's not just a exercise or a homework as you did for all the courses where we have a, let's say, so-called correct answers. You will be kind of evaluated based on the correct answer and so on. But here is, here we're really talking about ongoing research project. So you will join some projects which don't have the answer yet. Yeah, that's the whole purpose of this course. So we'll try to give you really very actual and the real world stuff, not just some exercises that, Nano or Lope and so on will correct you. It's not that case anymore. Yeah, so I will explain a little bit later in detail. So the beamer is making pause again. So I would like to start the course by this. Okay, I have to. All right, good. By such a quote, I don't know whoever has already heard or read about this quote. It says, "Scientists discover the world that exists." Well, that's interesting. And engineers create the world that never was. Have you heard of it? Do you know who? The guys online, you can also answer. Yeah, you can also interact with us. Do you know who said this? Not really. It's actually from a scientist or engineer, so you probably know him from Common. Yeah. And this is a code I like the most because we're engineers. We don't like, we like, but we think we're better. We're better than the scientists. So if you have a friend working in the School of Science, if you want to go there, remember you have learned this. Yeah. It's very nice because it's actually the truth. Yeah. You have learned a lot of, let's say, science in terms of theory, equations, knowledge, all the experiences from the past 300-400 years. And I think that's pretty much enough. Yeah. You will still learn something, but I think it's pretty much enough to really engage some creative things. So to do something that we don't have an answer for. That's the whole purpose and the motivation of this course. Maybe you remember, okay, some of you might think, okay, we're just like bachelor students, right? We're not mature enough to conquer very difficult problems. I can give you some really great examples. Do I have, okay, I don't have it on my slides. Before I go into this boring stuff, I can give you a few examples just to motivate you. I think everybody knows Newton, right? Okay. I think this beamer is really interesting. Yeah, so everybody has learned all the stuff that Newton created with mathematics, optics, and also most importantly on physics, like the theory of gravitation and so on. Do you know when he created all this stuff? Actually, they were all created at in dense years, about 2 years. I'm not asking the year. I'm asking about his age. Do you have an opinion? What? Oh, Isaac Newton. Yeah. Late 20s. Yeah. Anybody else? Pin, do you know idea?
I'm sorry, what are you asking?
Do you hear me well?
Yes, I can hear you.
Do you know a person called Isaac Newton?
Yes, of course, I think everyone knew him.
All right. Do you know his classic theories?
I think that I only remember his three rules on kinematics.
Yeah. Do you know his contribution on mathematics?
Yes, he
Like,
also
like calculus?
Yes, I know. I remember I read that he invented calculus when he was on his publication or something.
Yeah. So all this stuff, I think you also know his laws of gravitation. Do you know when he created all this, breakthroughs?
I think that in his 20s.
Yeah, exactly. He's actually about your age. Maybe just a little bit later. 1 year or 2 years, something like that. At his 21, 22, maybe 23, something like that. So
yeah, he's a genius.
that's the point. So you're at the moment right at this age to be creative. Yeah. If you're thinking, okay, that's a genius, like I gave you another genius. Yeah. Maybe you also know Albert Einstein. Yeah. So he created all his, relativity theory and the general relativity and all this. Also, there's a little bit about quantum, things. At also a very similar age, so a little bit later, 25, 26. But all this came in that year, so 1905. Yeah, I think everybody knows that magic year in physics. And so I have to say, I mean, these are two extreme examples. There are probably still many. You might know, you might can check. The point is, you are really at the age, I would say, when you are most creative, because you learn some basic structures, in your knowledge base. Because without some basic structures, it's difficult to really do anything. But you're still at the age to really do things without constraints. When you're just in the field for like 5-10 years, you're experienced, but at the same time, you're really losing some creativity. So now I think you solved it. Yeah, yes, you didn't do anything. It's not going away anymore. Yeah, and that's the advantage for all of you. Yeah, you're in the right good foundation, and to be creative, to really do things that we have never thought about, maybe. So that's the inspiration of this course. So I was thinking at the beginning to create this course. Let's do some homework-like assignments for these guys to kill these 2 periods and the 1 semester before they go to master. But then I thought, okay, that would be a pity. That would be a pity to waste your talent, a little bit of your time, because there could be one Isaac Newton sitting right in the class. maybe not that extreme, but I'm sure if you really gave very, let's say, concentrated thinking and let's say even investment in such a project, that will benefit your whole career, I would say. Yeah. So it's coming back again. Most likely it's from my computer. It's because it's working without electricity. All right, so that's all the inspiration of the course, or a little bit of background about this course. Now we can go into some details. And the details is, so you don't need to read all this text. You could read it from my courses. The core is we're gonna do a project in group, yeah. So the group is about 2 to 3 persons, yeah. And in this project, of course, you will have a supervisor who is me, and there will be also a daily advisor, yeah, and who are sitting here, 3 of them, and one more. Oh, when she's probably even not joining online, but you will meet her. You will see her topic a little bit later, and you will also meet her most likely virtually for most of the time. So we have 4 advisors to really support the daily kind of supervision to you, to introduce into the topic, to explain what are the tasks and how to carry on, what is the direction to be successful, and so on. A little bit later, they will just come and tell you what the project about. Yeah, and you can learn the details a little bit later and learn who they are a little bit later. So the course is, the project is typically computational, so most likely completely computational. So there might be no experimental work at all, but you'll be accessing some experimental data, some experimental knowledge, and so on. This is really disturbing. But physically, you don't probably have any experiments to do. Of course, if you're interested, we can show you around in the lab, but you don't need to do any experiments. Yeah. And the topic basically is in the field of mechanical and material, and also somewhat civil engineering related, not too much, a little bit, mainly on the mechanical and the material sides. Yeah. So here I'm giving you a few learning outcomes. Yeah. So what will be the learning outcome that you'll be able to do after the course? The first is to use computational tools to tackle a real-life engineering problem. The key is actually real life. I think most of you have probably learned some Python, machine learning things. Everybody uses some, or even compile your code to recognize 1 to 10 or 1 to 9 as a typical machine learning exercise, or something about animal and so on. Okay, they're interesting, yeah, but they're not real life problem, or they're a real life problem, but those problems have been long time solved. Yeah. So here we're talking about the really real life problem. It's a little bit engineering, I have to say. You need to have a little bit basic domain knowledge to get there, but we try to control this kind of knowledge as minimum as possible. Yeah, I know everybody has different background and you have different ambitions later. So we try to focus on the computational side. And if you fall in love with this engineering field, you're really encouraged to go for it. But in this real life problem, we try to take the most concentration on the computational side. So you will see from this, you see this picture from the detailed projects. And the second one is to develop computational skills and gain deeper knowledge in a specific field. So the first is something we don't need to really emphasize. Yeah. So you have lots of theories and even some skills. So here we want you really get some systematic skills. So you probably like something like machine learning or Python scripting, but you don't know how to make data structure and how to make visualization and how to write a manual afterwards. So we're trying to give you a systematic training about this whole process. So you're lucky you would do it in a group, so you can really make distribution of the work. Yeah, but you will see how a project, I would say, at the company looks like. Basically, you will have a topic, and a small group will be formed, and then you basically do this project, in this group. Okay. And the second is, anyhow, you will get a little bit deeper knowledge in a specific domain. Yeah, I mean, it will be limited, yeah, but you will know something at least. For example, there's one or even two projects of crystal plasticity modeling. Yeah, that's something, okay, you have no idea what it's about. If you do those projects, you will know quite something about the crystal plasticity modeling. You will know how deformation is happening. Yeah, remember from material science engineering, there's dislocation, sliding, and so on. Then you could use simulation tools really to mimic these responses. So what is stress? What is the strength? So you will become a certain level expert in a specific domain, not too much, but you will learn much more than before. Yeah, that's the second. Okay, now how to go to the third. Okay, the third is to work effectively as a team. Yeah, maybe that's the somehow most challenging thing for you guys, because I don't think you have worked in a team yet, at least from your courses, maybe not, right? But this is going to be the first thing let's say the newest thing for you to learn, because if you don't pursue a master program, you go to a company, so everybody will work in a team. You will join a team and you will see the tasks, and you're going to know how to distribute tasks, how to collaborate in a team, how to blame each other for their faults. So you will learn all these tricks and experience this, let's say, teamwork. In the end, if you manage well, it will work like brilliantly. But if you're lacking of communication, if you just don't talk to each other and really blame each other, that will add up with a disaster. So this is experience you can really pick up early enough now. Even you make mistake here, it's not going to cost you anything. You can learn this skills and this spirit and do it in your later projects or in your career. And to make kind of mistakes is also part of the education, right? Especially for undergraduate students. And lastly is to learn how to write a report and how to discuss in your teams, so with your peers and also with your advisors. In the end, you will also be given a chance to present what you have developed. And even better, so we will hopefully form enough teams, because if now we have only 6 people, it's a little bit lacking of teams. We have actually 6 projects. But I know some people are not joining right now. They're still checking and waiting, maybe. So try to remind them to be here to join the course as soon as possible. And because later on, the most important thing is to select your topic. And after everything is finished, I mean, in December, this is really annoying. In December, we will have a demonstration of your progress. So most likely you would do it via presentations, because we're doing, computational development. It's not like a product development. You can really take your stuff and show to everybody. So usually people do a presentation in a team. Once again, like, have you seen for example, Google events or Apple events? So there will be one opener, and then your team member will back you up with some specific
hardware, software features, and so on. Yeah, you will do it like that. And we'll have a jury, and we will evaluate your presentation and your progress as well in a team. And a best team award will be given to the one that gave good performance. It's not just the title. I mean, the title is interesting. There will be also some nice souvenir from Aalto. Yeah. So, oh, I'm missing. Well, I think we can most likely in this year's my courses, you can just attach the reports from last year. So we have 4 groups last year, and who all made really good effort and achievements. You can just feel what it's about. Yeah. And there's one team who made really outstanding contribution. They achieved some results, I would say, could qualify to a certain level of a graduate student 1-year work. It's a very nice contribution from one team for half a year. 3 very good students who did that. Of course, they got the award, and we got some nice souvenirs to them. So you can get the touch about it from, I was just to upload those reports to this year's my courses. And yeah, so we have something to grab, I would say. Yeah. Okay. Any questions so far? Guys sitting here and online? No questions?
I mean,
Not yet.
Oh, Pin, just 1 second.
oh,
Yes.
Apart from the report, you also have the presentation, right?
Yes.
That's the same as the workshop in one courses.
Oh, yeah. Yeah.
right.
It's the same. It's the same. I will tell you that.
Yeah. Pin, what's your question?
I am just wondering if this course has a LaTeX template.
Oh, good point. No, we don't have.
Oh, really? I really want to work with LaTeX.
Well, you have the Word tablet, so feel free to create one via LaTeX.
But there's a problem. There is in the formatting document file. It
Yeah.
sets the bold like some kinds of fonts and also spacing, like some formatting in words, and I don't know how to do that in LaTeX.
Oh, I see. So LaTeX cannot do bold?
No, I mean, that there is some specifications defined in the doc file on my course.
Yeah.
I think we have to abide by that, like the font type and also the font size spacing and some other things. But these are applied to Microsoft Word. So I am thinking if there is a LaTeX template that also has these specifications.
Well, you don't have to stick to a certain font type. Yeah. If you don't have, I think we chose Arial. If you don't have Arial there, just to choose one that is common in LaTeX. About the line spacing and so on, try to approximate those, because that is a factor about page number and so on.
Oh,
We don't want to differ too much. I think we defined by default the line spacing is probably 1.5 line and so on. So if you could manage it, that's great. If you couldn't, then try to go with, let's say, one line or so. That would be good. And the font size the same. So try to stick or approximate the similar font size.
okay,
yeah,
okay.
But we're not absolutely strict on the template. Yeah.
You're not absolutely strict, right? I see.
Yeah. You can definitely use a similar template to do your report. Yeah.
To be honest, I'm actually want to use the Bachelor thesis template for this project.
Well, feel free. That's a good idea.
Okay.
That's also a good template. Yeah, the template we recommend is really a recommendation. So you don't have to stick to it. but I don't want you use some weird template that feels like a presentation file, because it should be a Word file for a report. Yeah.
So it means that this template is a freestyle, like we can do everything, like we can make it style as anything as we want.
Yeah, stylish way, it's okay, but you should stick to the headlines that we gave. Yeah.
Yes.
Okay.
It is not strict like the bachelor thesis, I see.
No. Yeah, I will explain you a little bit in detail about all this stuff. Yeah.
Yes, okay.
Good. All right, I think everybody's clear right now. Let's move to some details. Yeah. And it's about class structures and the times. This will clarify some thoughts you might have or doubts you might have. So right now we're happening this so-called kickoff lecture, and this is about the introduction of the course. And then the second event we will have is so-called Computational Engineering Seminar 1. This is going to be happening via a Zoom link. It's actually a webinar. So if you want, we can come here to invite our guests. Definitely possible. But the guest lectures will not be here, because we usually invite them from, for example, as I mentioned, other countries, Germany, Europe, just to be different, to be a little bit different from what you have learned so far. To see how, let's say, anything computational out of Finland is doing. And they will make presentations, and they're usually early stage. They're usually early stage researchers, so most likely second, third year doctoral students, something like that. So you will definitely benefit something from their presentations. So their content, their method, maybe the way they make presentations. So the benefits will be multi-level. And so that is October 12th. See, we have 1 hour about that. It should be one webinar only. And then October 21st, it's a first draft report of your project. So this is a very draft report. I think we might have some description. Okay, not really here, but you will learn this from your advisor. We're not trying to really get you write a nice introduction and so on. But the most important thing is we want you to realize what has been going in this project. Get a basic understanding and write what you have understand it in terms of state of the art, and what is your methodology you're gonna resolve this problem, and then maybe some outlook of your future plan. So this is in a range of 5 pages, more or less. So it's not a lengthy report. It's just something to kick you really start working on it. Okay, and then we will have the so-called midterm review workshop. This is the presentation stuff. So the midterm review workshop will be containing 2 actions actually. The first part, we will have again a webinar. So actually there will be 3 webinar in this whole course, but the second one is combined with the review workshop. So you will hear another presentation from somewhere just to get you prepared. And after that, most likely 1 hour, and each group will have the chance to present your work. So the presentation will be about 15 to 20 minutes. I mean, at this stage, you most likely figured out what is the topic about, but you probably don't have solid results. That is completely fine. So this presentation is really to check you have understood the projects and you have a plan to go on, and you got your team kind of working.
not just everybody is doing individual stuff. Yeah, so we encourage vivid and really detailed discussion among the groups, and you could ask questions to each other and ask how they kind of divide the projects, how they do the teamwork, do it online or kind of on-site and so on. Yeah, so that's the midterm review workshop, and after that you will get certain feedback from me, yeah, but there will be not so, let's say, content-wise. It's more about really your teamwork and your understanding about this project. And then November 23rd, we'll have another computational engineering webinar, let's say. Yeah, so this is the so-called second, but actually it will be the third, as we'll have a midterm review workshop with a webinar too. So for the webinar, it's just attending. So you listen and ask questions. So most likely I will choose someone who has some experience in the topics where in the projects that we define. And you might be able to get contact with them, establish a certain collaboration, and ask questions and so on. Someone could get a PhD offer from this study in the future. Yeah, so these are good as kind of context to make. Good, and yeah, this is the webinar, and then we have December already close to the finalization of this whole project, second draft report. So here we're talking about how many pages already?
For this is 20 pages. For the second draft will be 13 or 14.
All right. So basically, we're aiming at 2/3 of the final report at this stage. So you might be missing some final results, but I expect a complete introduction, state of art or methodology or something. You have already complied. Yeah. And then we have the final workshop. So this is the final thing, basically. So that will be December 13. So this date is a little different from my courses. I need to ask people from my courses to make an update over there. I just want to make sure you guys are fine with this date, because on 15, I think the original date is 15. I'm not available. Yeah, so I hope 13 you're all fine. If you have issues, please let me know. It could happen even last year, because it's going to be a long day, from 9 to 12 or to 13, because everybody will present and everybody will fight for their results performance. What we need to make sure is you need to be there when your group presents. If you have other errands to run, you can also skip for other groups. Yeah, but this is the final day. Yeah, that's the most important day. Oops. Now you have group presentation for about 20 to 30 minutes, including Q&A, just longer. You can really make a nice show over there. Good. And 1 week after that, so we will expect your final report. Yeah. And so this is about some details about the final report. 20 pages per each group member. Yeah. And the template structures and so on. You could find all in that doc file. But if you have, for example, like Ping, you would like to use LaTeX, feel free. Before you do everything, just double check with your advisor. So make sure the template is not something completely out of our field. And usually we're fine with the style. Even the content can be a little bit different from a thesis. So don't think about this is a thesis, because we call the report. It's not a thesis, because you will have a very good training next year when you write your thesis, about how to make citations, how to learn the literature, and so on.
So we're not trying to give you like 20 papers to read and then write stuff. You usually follow around about 2 to 5 papers, yeah, highly relevant to your project. And then I want you to get hands-on. So you do stuff really, you resolve a problem in the real life. Yeah. So the report can really be very practical. If you, for example, design a software in your project, we have one project is a little bit like designing a map or designing software. Well, you can write something like a manual about that software and you make some nice screenshots and explaining your design idea and how you implemented this interface and so on. So it's really a little bit less strict, yeah. So you can be creative with what you write. Of course, the conventional one is starting with the introduction, state of the art, methodology, results, discussion, conclusions. I mean, you can follow that for sure. But you also don't have to. Yeah, you can be creative. Yeah. Oh, Ping, you have a question.
Well, I just copy one of my page from my LaTeX and then paste it on Word in the same format. And I am glad that it fit nicely. You know, the words, my LaTeX template now is exactly like Word specification. So I think I will continue to use my LaTeX.
Very good, Ping. So maybe you can just send us back your lattice template later. We will provide that as a template to everybody as well. Yeah.
Yes. Okay.
Great. Thank you. All right. What's next? Yeah. Then December 27, thesis evaluation. Is it? Yeah. This evaluation. Yeah. So actually, this does not concern to you. This is a job for the advisors because they will be working with you and they will finally also assess your performance. Yeah. So I'm just sitting here and watching. Yeah? So I will have a look at their suggestions, their arguments, and everything, and make a discussion if this group or the student is really performing outstanding results or social and so on. And then we'll give you a final mark on January 3rd, results of the course. You will receive this from my courses as usual. Yeah. All right, I think this is the whole timeline. So let me know if you have any questions.
I have a question.
Yes.
For the results, is it like a conventional course where we get grade from 0 to 5,
Yes.
or just pass or fail?
0 to 5. This is a course with a 10 credits. So you could really get a good GPA for 10 credits. Yeah. All right. Yeah.
What will the grade be based on? So, are you gonna just see the report and then make the grade based on the report?
Very good point. Okay, do we have a slide about that? Most likely no. But you'll be able to find from my courses. So there's an evaluation criterion. It's a Excel file or it's a PDF. Yeah. You will see we have 4 categories about the assessment. Oh, I think we have it. We even have it later on. Yeah? Let me show you. But anybody has any questions about the lineup of the events? Everything's fine. Okay, then I just move forward. What about the guys online? Do you have questions about the lineup of the events?
Let me see. This is evaluation reports. I think about the daily evaluation. So what does it mean to evaluate daily? I think that I have to study many courses and also like there's a job, so I can do this on every day, but I will do it on specific days. So is that okay?
All right, yeah, being very good. So daily evaluation is just a general term. Yeah,
Yeah.
that's a evaluation just for your daily work. not your specific daily work, but just in general, the daily work, except for some specific events like midterm workshop or final workshop. Yeah,
Oh,
it's a general term.
okay.
Yeah.
Originally I thought that like Rongwei have to check my progress every day.
Okay. No.
Okay, I see. Thank you.
Otherwise, does not have so much time either to check you every day. All right,
Okay, I see. Thank you.
good. Oh, Hongfei, you made another animation. Yeah, project work in team. So it's just another emphasis about the really teamwork. So that's really crucial. Yeah. Good. All right. Oh, I have to save the assessment question a little bit later, because now we're gonna go through some topics. Yeah, and you're interested probably in what the topic's really about. Is it about discovering a physics law or so? So as you can see, we have 6 topics, and belonging to 4 advisors. So surprisingly, they're all girls. Yeah, that's impossible. How come for an engineering course? So many. Yeah, good. So the topic number 1 is optimization of nano indentation related to crystal plasticity parameters. So this will be advised by Wenqi Liu, so Dr. Wenqi Liu, who is not here. Actually, okay. Who is not here today, but you will be able to access him later on. So I will just give a detailed description about topic number 1 very quickly. And then the second topic is by Rongfei. So Rongfei is sitting here. So you probably met her before, right? And she was the secondary teaching assistant for the material science engineering course. And her first topic is optimization and visualization of the calibration processes of crystal plasticity model parameters. It's pretty long, but the key point is the first 2 words, optimization and visualization. That's very interesting. She will introduce the topic in detail later. And the third one is also from Rongfei, her second topic. It's about damage simulation, and so CP stands for crystal plasticity. Model optimate output in Damask 3.0. Damask is basically open source software. Yeah, so you probably don't know what it means now. Don't worry, you will learn it in about 3 months. You will become an expert, in everything here. So these are the 2 topics from Rongfei. You can see they're about a lot about optimization and the visualization, automation. So these are the computational spirit, and the basic domain knowledge is about material science and also something about mechanics. And the 4th topic is by Zinan. Zinan is sitting here. And her first topic is automation on strain rate dependent. So HSS stands for high strength steels modeling. Yeah, so it's about the steels, but actually it's about any metal in a general way. So this is about somehow already about, is it about machine learning involved? All right, yeah. So then I will give you more details later on. And the second is the automation on the damage locus fitting. So this is really a working title tonight, right? Isn't it? Okay, yeah. So you will get the more specific description in the detailed slides later on. So the 2 topics are kind of machine learning heavy, and it's also not too much about material science. It's really about mechanical and civil in a way. And the last one is by Chen. So Chen Minggu is sitting there. And her topic is about optimizing
laminate design via parametric studies of materials and manufacturing parameters. So this is a optimization and design task, very modern. It's about battery material. Yeah, so all of them are doctoral students. So some will be early stage and some are pretty mature already. So I'm sure. Okay, except for Dr. Vinci Liu, she's already a doctor. I'm sure they will be able to provide you very good guidance to get into the topic. Yeah. But as I said, so all these topics are ongoing research. So you don't have an answer for anything. They don't have an answer for you. So basically, you will develop really in your team for some nice achievements. Yeah.
All right. And I gave you a introduction about topic 1. And this is by Wenqi. So the topic is actually pretty, I would say pretty straightforward. So you see there are some nice colors, you know, about FEM simulation. And this is some map from material science. So this is a material science map. Do we have a scale? Yeah, you can see
Here's 1 micro. That is 1 micro.
basically. So if you just line up this figure 1,000 times, it is 1 millimeter, something like this. So this is a figure by very advanced microscope. You can see the microstructure features. The challenge here is we try to describe some material behavior in nanoscale. Yeah, that's why this guy is called Nano Indentation. So I think everybody knows indentation, right? Yeah, basically, this is indentation. So we just indent something. You feel the pressure, you feel the force. You're not doing any deformation on the desk. You're doing deformation on your figure. But if your figure is really tough enough or stiff enough, you make deformation to the table. If the table is stiff, you'll get a little bit deformation with a certain force. If the table is soft, you'll get a lot. Yeah. So the point is here we want to characterize the material in nanoscale, right? Because the nanoscale matters to their final design. And we want to see how can we describe their mechanical behavior via the so-called crystal plasticity model. So this is a complex model. You have no idea at the moment, but you know, it's just a bunch of equations. It's so simple equation, you know, F is equal to m times a, and then you can easily correlate F with velocity, acceleration and mass. But here the connection is not that straightforward. You need to solve a lot of differential equations. But in the end, you try to correlate the force from that test with certain material parameters, with certain material microstructure. So those correlations were described by this so-called crystal plasticity model. You don't have to know all the details. You can get a basic theory. The key is we have a few parameters to describe. So F equal to ma, there's no parameter. But if you think about the gravity equation, there's one parameter, so-called G. So that's a parameter Newton calibrated for us. It's 9.8, right? Isn't it? Do you still all remember that equation? Yeah, good. But for our law here, the parameters are a little bit tricky. So you don't have a constant. It's a material dependent. For aluminum, it's one parameter. For steel, it's another. For ice, it's another. So ice is also crystal, by the way. So the job basically is to find a way to optimize those parameters. So you will have a lot of data from experiments, from simulation, and we want to find out the right parameters to describe this material. So in the end, it's an optimization application. So if you have a few optimization skills, if you know genetic algorithm, some Bayesian algorithm, or even machine learning algorithm, because machine learning is also good at to do optimizations. I can tell you most of the engineering work is related to optimization. You're probably not because you don't do any real projects yet, but most of the engineering work is really about optimization. Yeah. Another feature is you will get used to, or you will learn how to run FEM simulation. So these are done by FEM simulation. I think you have basic background about FEM from 1 or 2 courses. Now you'll be able to really apply those knowledge into a supercomputers in Finland. So Finland just built, I think, the second most powerful supercomputers in the world. And as students, well, as a specific group of students, because not everybody could access, but in this course, we have free access to those supercomputers that you can really run stuff over there. All right, I think that's my description about the course. So there's some animations here. So this is the one you can see. Experimental curve is black and the simulation curve is red. So this is the goal we want you to reach. Yeah. So here it is done by human intelligence. Basically, when she did it via trial and error, maybe 100 times or so. And now we want to make this really, let's say, automatic in a way, or even smart. So we don't have to go to learn its patterns on our own, and you can do it via certain algorithms. All right. Okay, so here are some details about different indentations from different grains. So you will be really getting used to all this knowledge afterwards. And here you can see the main objectives. Yeah, so it's about the FEM simulation, and the second is about the algorithm of optimization you're going to develop in the thesis in this project. There are some tasks required for this project, so I suggest you to try to read it in a little bit detail, because we will not have enough time to go through each one detailed tasks, but you could basically get a sense of them. Do we have one more slides? Okay, there are some learning outcomes as I described already to you. So first you will get the so-called optimization algorithm knowledge from this project, and then you know how to run crystal plasticity model, and you know how to run FEM simulation. And lastly is about writing a research report, I would say. I think that's all for project 1. As Wenqi is not here, do you have any questions to ask about this project? If you have detailed questions, you can always write email to her right here to consult about this project, some details. You'll get responses.
Can I have a question?
Oh yeah, Ping, what do you have?
I think that from the Damac simulation, they return some values for the two stress, two strain values. In these figures, the graphs looks very weird to me, because it is not a stress strain graph, but it is the force and displacement.
Yeah,
and
indeed.
yes, and there is a line that goes down, so I don't really understand what is this line going down here.
Yeah, very good observation, Ping. Because now we're not doing FFT simulation anymore, so it's not about Damask. It's about FEM simulation. So you're really doing a so-called digital twin of your experiments. So the indentation that we do in the reality via a machine will be mimicked in the simulation. So you will get the force displacement curve, from the machine, and you will also get this from the simulation. Yeah. So
Oh.
it's not about stress strain curve anymore. It's about the force and displacement.
Oh,
Yeah.
I see.
So yeah, it's a different system. So this is a FEM simulation. Yeah. So it's good. You mentioned about the FFT and Damask simulation.
Oh, then what does it say here? It say Abacus plus Damask CBFEM. So this is the one that is different from what I'm using.
No, we don't have Damask anymore here. So this
Oh, really?
it's there's Damask CPF, yeah. It's more about Abacus CPF, yeah. So Damask shall be deleted here. Yeah.
Yes, I think you should delete the mask because if we don't use it, then it's misleading to put there.
Yeah, exactly. So we don't have the mass simulations to run here. Good.
Okay.
All right. Okay. Oh, still one more. So this is about the task and the time plan. You can get really a view about this time plan. So up to September 3rd, 30. So end of this month, you will get the thing about kickoff and a few literatures to read. Yeah, and learn how to run the simulations on so-called CSC platform. This is the supercomputers in Finland. And you will learn some interfaces and codes how to run simulations on CSC. Yeah, and then you have the really project development phase from basically October until beginning of December. Yeah. So you can see some detailed tasks planned for this project. Build up the single grain, and you can definitely consult with Wenqi about what they're about if you would like to know the details. But I would say this is more about when you really get into the project, you will figure out one by one. So here you can see everything is arranged nicely. And if you think you're interested in the general methodology or this field, then you can talk to Wenqi and join this group. Yeah. And then it's about the report writing and workshops and so on. I think this is a repetition about the timeline I showed you at the very beginning for everybody. All right. I think that's all for project 1. Now let's welcome Rufei to introduce the second project. Yeah. Good.
Okay, first, let's thank Professor give a very detailed project 1 introduction, and then I will give compare with him. I just give you very quickly and roughly introduce about my project. My project name is optimization and visualization of the calibration process of crystal plasticity model parameters. And we have aim is focused on the optimization and the visualization. Totally, sorry.
Just click it. Now you will have
Okay. Totally we have 3 objectives, and the first one we need to optimize the automatic parameter calibration process. Now we have exceed parameter calibration process. It's created by PIN, and by the last COE project. Group 1 and the PIN has helped us to optimize it again, and now we need to optimize it again and again, and extend some others function, and it's the first objectives is validation of the effect of the material parameters and different loading conditions. I will detailed to introduce about the objective tool. And finally, we need generate a user interface. For this picture, like a graphical user face, and we input some models conditions, and it will output some during the parameter calibration, we will get a series of parameters and give the loading. Here is the curves of strain stress and output some strain stress curves, and some outcomes we will get some knowledge of programming by Python, and some knowledge of crystal plasticity, finite element modeling, and some CSC and Damask application. And for your research, this is writing. And here is some detailed task about the project too. First, we need to understand the parameter setting of the CP models and different types of deformation experiment. For example, I just give two types loading conditions, and this one is linear loading, and we get 7 degrees interval to do the tensor test by 7 directions. And for this one is loading conditions, we have 3 types: nonlinear loading, deformation. And the task 2, as I mentioned, we need input a stress strain curve, and we will and after the calibration process, we need it to output the parameters of the crystal plasticity model. And the third task, when the model have served some different deformation, like both the stress strain curves after deformation was showing by automatic programming plotting. Finally, we need to combine all these tasks that we can get a final user interface. Here is the whole project story, and now I will continue with the third project. Is damage simulation and the crystal plasticity model automatic output in Damask 3.0. It's a little bit different with the next project. It has the same start, but it's 2 direction get the result. The aim is focused on the output and the scientific plotting of the CP models, and the project 2 is only focused on the parameter calibration, and this is more focused on the scientific plotting, different with different simulations and different results. So the objectives, here are the 3 objectives. First, we need to update the Damask into 3.0. Now we have used the 2.0. And the second objective, we need define the damage related parameters or terms. And the third one is to validation of the CP and damage simulation result output. And the learning outcomes, the first is knowledge of programming by Python, and the knowledge of crystal plasticity modeling and the parameter sensitivity. And the final one is the same one, scientific writing. This project will connect the Damask 3.1, 3.0, and use the Python and MATLAB. And we need to call in the Parallel to achieve this project. Here's the detailed task introduction. Of the first one, install the Damask new version, and the second one is our main work at the project 3. The visualize and automatic the output. We need to do the output the different state of a certain grain. Here's our respective volume element, and here's so many grains in there, and we need to output the a certain grain or a certain moment in the deformation stage by calling to the software such as I mentioned, Parallel through Python, for example. And the final task, we need to extend it with different simulation like damage and deformation and different outputs. I can show you the two figure here. Here, the blue one is ferrite in steel, and the red one is martensite in steel. This picture shows this location at this time is deformation and is statement. So the final result we need achieve one code or one process to help us automatic output this result. Okay, here's two projects on mine. Thank you. If anyone
Yeah, any questions? I think everybody is completely lost. Yeah, it's, as you can see, it's really difficult. It's difficult stuff. I'm sure you are lost right now. But as I said, in about 3 months, you're going to become an expert about this. You're going to make a wonderful presentation about all this stuff. Yes.
So when these slides we uploaded.
Yes. Yes. Right after the course. So for these two projects, I can give you just a little bit sense about it. So the first one is algorithm mapping. So if you like algorithms, and if you like some physics, of course, that is well suitable for you. So the second one is visualization. So this visualization is basically using data to make plots, like like anything you see, like Google Maps. So basically, people use data from the maps, with the latitude, altitude, and some color rendering and so on. Basically, here the colorful things are the aim. So you're going to do this visualization using Python, using Parallel open source software and everything to visualize them. It's visualization heavy. It's not about really some genetic algorithm and stuff like that. But we need to define very good, let's say, program structure, how to manage your data, how to manage your class, how to use functions and all this stuff to really get all these plots efficiently. Good. Any questions on site, online?
Oh, so this is Damask, the 3.0 installation is in this project. I see.
Yes, exactly. So we have one guest who is called Kay. All right.
Oh, hi, Kay.
Very good. So at least you know each other.
Well,
Awesome.
actually, we are thesis opponents.
Good.
Which-
So Kay, welcome. You're a little bit late. But this slides will be uploaded to my courses. The recording will be also uploaded to most likely, as we always do on YouTube. But then you can get the link to watch it if you have missed anything, if you want to recall anything.
Well,
All
wait, can I have a question?
Yeah.
I remember that on CSE there are two groups. It is the crystal plasticity, and another module is damage simulation. So it means that this project 3 will be assigned to that CSE group, right?
Yeah, Pin, that's very likely. You're right.
Well, yes, because on CSE I see that there are two different groups, right?
Yes, you're right. We might even create more groups. So we might create really specific groups for each topic. Yeah.
Yes.
So that's something you can always do
Mm,
as a researcher working in Finland.
okay. But if this project 3 is doing some damage installation, so does it affect other groups like group 1 and group 2? No, I think only group 2.
That's a good point. Yeah. Well, that's something you can really coordinate with the Rongfei, I guess. If you want to do those two projects, one of them, you can really coordinate with the Rongfei how you're gonna work together. Because you have to choose one version of Damask. I mean, you don't have to choose Damask 3.0 in a second group, but this could be completely independent as well. Yeah.
Independent. Oh,
Yes.
so it means that you can install two different versions of Damax on CSC.
Yeah.
Oh, okay. If that's the case, then it's no problem.
Yeah, indeed. Any questions? No, everything's clear. All right, now let's move to the fourth topic, which will be explained by Zanan. Yeah. So now you're really using all the space. I think everybody reads pretty nice. Yeah, go ahead. You're missing something.
Yeah, so
Or something is not. I think Rolfe made some nice animations for all of us. So you want to start with this project?
yeah.
Uh-huh.
Yeah, so the project 4 and 5, you can see they are all related to this high strength steel material. So like Professor has already emphasized that. So the project is to solve or to connect you with the real life problem. So it's a problem driven project. So this project 4 and 5, they are all related to this model calibration process. So I think you don't know, but you are quite familiar with the high strength steel actually. So it's used quite widely in the automotive industry. So for the cars, for the vehicles, these structures and also these components for the crash rods and everything, because of the lightweight design, they want the car body to be as light as possible, but they also need to maintain this certain strength level. So the high strength steel is developed for this proper use. And because it's so important to the industry, we want to have a thoroughly understanding of the material property. So for example, the structural damage behavior is when the damage happens, how this material will react. in the mechanical. So for this calibrating process, normally we use the hybrid experimental and numerical method to do a tons of tests and then use this data to calibrate the model. So it's very accurate in some way, but it's also like time consuming. So we want to replace this process with the machine learning because it's really fast and we can kind of imply this our optimization and automation process into the process. So for the project 5 is a the calibration process for the fracture locus. So you will have these different data from the experimental results that we already have, and we use the machine learning model, probably the neural network model, to have these 5 times n, which is the data set, the frame dimensions that to correlate with the 5 parameters in this model. So to have this whole process workable, we will begin with the data generation, and then to fine tuning the model and to validate the model at the end. And similarly in this project 4, which is to apply a similar model in a different loading condition. So like we have different mechanical behavior under certain loading for different temperature and also for different strain rate. So the strain rate is when you have to say like in a low speed or in a higher speed. So the response may be different. So you can see from the figures that they are all implied from different strain rate. So this will also affect the model behavior, and we want to have a machine learning model to replace the curve fitting in this 2. So we have 2 parameters in this model for the CT1 and CT2, which is the temperature base or the strain rate base model. So we will have the automation of the calibration process at the beginning for this strain rate dependent damage locus model. So these 2 projects, they are quite similar with each other, but they also have different aspects. So we have more detailed instructions in the workflow. You can refer to that later. And if you have any questions, don't hesitate to ask me. I think. Oh yeah, and also there's a timeline designed for each week according to the study schedule. So we will have different tasks and subtasks for a different stage. But yes, you can read through it in details, and we can discuss about it in the bulletin session.
Good, so thank you. We want to go through the weekly tasks as well. I mean, everybody actually sees them.
Yeah. Yeah, so first, we will have the like every study or the research goals, we'll have a literature review on the especially for the inverse fitting, curve fitting for the calibrating the model. And then we began to choose the database and the descriptor for the for our defined problem. And then we began to create for the training data and testing data as the input, and to think over what should be the label for the output data. And then after we have week 4 to 6, we will do the modeling together to see how it behaves. And at the midterm review, we will present as this current progress. And after the midterm review, we'll train and testing the data, and finally for fine-tuning the model to have a better behavior and as a validation for the overall behavior. And finally, the final report and the final presentation for closing this project.
All right, thank you, Zenan. Good, I think this is the end of the 2 projects. Yeah, I think it was pretty clear. Yeah, it's very connected, most likely, to mechanical things. I think you have good background in that sense. Yeah, so any questions, feel free here and online. Yeah, as you can see, it's pretty machine learning heavy. Yeah, you will most likely get a few approaches over there, and probably CNN as well to do the kind of time sensitive things about strain rate dependency of material stress strain behavior. Okay, good. If there are no questions, let's move to the final one. Yeah, that will be given by Chemi. Yeah, so welcome, Chemi.
Okay, so my project, the name is Optimizing Laminate Design by Parameter Studies of Materials and Manufacturing Parameters. So the material that we are going to build is some kind of multi-layer laminate, and it can be bearing the components. For example, here you can see a polyethylene and some kind of copolymer, which is adhesive that we can how can I say, attaching was a polymer layer, and here aluminum foil, and also another adhesive, and also another polyethylene. So yeah, actually the components can be very bearing. And my research is about the laminate battery. So I'm doing some kind of packaging material for battery, but actually this kind of packaging material is everywhere in our everyday life. Like you can see in here. And so the fabrication of this packaging material can be reproduced by finite element simulation as well. For example, if you think about battery packaging or any other scale shape, we can make some kind of scale shape drawing, and we can compare with experimental data, and also some kind of copy capture or whatever. Then we can make this kind of round thing, and also compare with experimental data. This kind of finite element simulation, yeah, CAE will be applied. So the optimization process will be multi-layer laminate design and manufacturing parameters by computer-aided multi-scaling modeling. And I think the platform that I will use will be mostly about finite element simulation, and we will optimize parameter using MATLAB or Python. So learning outcome will be knowledge of programming by Python and MATLAB, and we will do multi-scaling modeling, but mostly finite element simulation. That kind of scale will be applied, and material, yeah, and the finite element simulation. Our barrier structure and scientific writing for research thesis. So I think I used to have another 5 thing in here. So what we have to think about is, first we have to think about the material hardening, because we have different 5 material, different material like aluminum and sometimes steels or sometimes polymer. So we have to think about, you might know like stress strain curve, that what we can easily call hardening behavior. And then yeah, this one like plastic elastic, if you ever heard about that. And also we need to think about formability. Formability, we can think about fracture and damage of things. So we will do a lot of, probably do a lot of parameter study about various different material parameters or intrinsic parameters, hardening parameter, fracture parameter, damage parameters. And then because it is also about the foaming, we have to think about the foaming, which is foaming parameter. It could be foaming temperature or foaming velocity, those things. So that would be another parameter sets. And you might think, okay, there are too many parameters, and how can we correlate them and make something out? And I think that would be by energy concept. You can see in here how there is, just for example, when we think about how they are attached well, we can think about adhesive energy or cohesive energy here. Or also when it comes to foaming, we can think about some kind of external energy as well. So what I was planning was not here, I don't know why, but I want to make some kind of foaming parameter or foaming design maps, which could be multi-dimensional, or like the professor introduced at first, we can make some kind of really simple platform, some kind of software, really simple one. Yeah, so we can think about various situation and make optimized design according to our material set or foaming parameter set. So here will be my task breakdown and time plan. So first I want to do a literature review and about the parameter optimization method, and we want to do data collection of individual layers and laminate together at first 3 weeks. That will be in the parameter and material data collection. And then we might have already too many parameters that then I want to do simplification so we can make, so we can, how can I say, organize the parameter set really clear, like categorizing parameter and data. And we will do optimization at first, and we will apply some parameter optimization method or platform already. And we have to do validation at first, so we can see that it is working well or not. Probably we can compare the result with research review or experiments data that I have. And then we will, if that was not good enough, we will do modify that optimization platform or the method, or we will try to figure out what would be better idea that we can apply. Yeah, and then if we think that we already have some kind of optimized set, we will apply to various material, like various layers or various design, various forming situation. Then we have more and more data that we can create something at the end, whether it will be multi-dimensional map or some kind of platform, yeah, software. And then writing the assessor report will be the last one. Yeah, thank you. That's all. Thank you.
Thank you, Chami. So any questions to Chami? Completely lost. Yeah, as you can see, this is the real world problem. It's a mess. You know, it's not like your homework. You know, okay, I should apply this equation and then should have got this answer, and then I know I'm pretty correct. I can look up in the textbook and find what are these equations about. I mean, real world problems are just like this. You have a lot of information. You have a rough directions to start with, and then we do it. We do and check, we do and check, and we see the progress. Yeah, so this is how it's about. So you don't have a clue, or you don't have a very clear clue at the moment, but I hope you now get the sense of the project. So you probably can sense a few familiar words, not all of them. I think you get the most familiar words from methodology, most likely. Yeah, so that's a good way to choose. I mean, the other is about the domain. Yeah, if you are interested in metallic materials, if you're interested in polymer materials, this is about that. Yeah, if you're interested in different fields, automotive, yeah, over there, material science there, and here is about manufacturing and battery, lithium ion battery and so on. So you have different multiple perspectives to choose. Yeah, you can see that the style is also different because they're really the leaders of this projects. So they prefer their way to manage the project, to lead the project, to coordinate the projects. Yeah. Yeah, I think they're all exciting. I mean, I'm very happy to see all these projects happening because they're really creating something new. Yeah, very exciting about the optimization, automation programs. And you could really make a big impact from all these studies. Yeah, which could lead you to a nice CV in the end. Yeah, you can put in your CV when you just interview your master program or to a job. So I developed this, this software or this algorithm from 0 to full, to 100%, 50%, 80%. Yeah, we designed this algorithm, we made this interface and everything. This is really, I would say, breathtaking if you are graduating from an undergraduate program, because no employer is really expecting that. You just look at the GPA, okay, oh, you are good. But some internships maybe, but they're not expecting something like this. So you can really be very compatible already after a good performance on any of those projects, I would say. I would be very happy if these projects are successful to get any of you, to do a PhD program. Yeah. The group that performed very well last year, I was very eager to get them to do a PhD program, but I think they went to some other universities afterwards. Yeah, good, but that gives you a good chance, to go somewhere else as well. I think that's really a good, nice, let's say, way to make your academic life, research life more interesting. I think now we can move to the next stage, which is about, so you see 6 projects. Now we have 8 people or so, maybe more afterwards. So because I would expect most of you will go for the projects. It will be a little bit because you are now already sitting here, you learn all this, you have a little bit advantage to the others who didn't show up or who didn't join, to choose the projects. The next thing is how to choose it and how to do the team up. I think we have a few slides, so Rongfei actually made all this, and I will invite her to just explain us how this mechanism works. Yeah, Rongfei, come on.
As the pictures I said, first, you open the my courses page, and in the left, you can see few topics, and you can select the topic and group section, and then you click the COE project topic selection, and then you can find 6 topics. For example, if you click the group 1, you choose one topic and participate in, and there will show save my choice. If you have already saved and you want to change your selection, you can remove my choice and select again. Here the steps, the final step. Okay, this one.
Oh, that's all?
Yeah.
Okay, very good. Okay, only one slide. I remember there are a few more. Okay. Yeah.
Like we only have like what, 8 people and it's like 6 projects. What if you choose a project where there's only like one person was selected? Is it gonna be a cancel or?
Yeah, that's a good point. So first of all, I don't think we will have 8 people really, and that's the first thing. But there might be the case, as you can see, we have six projects, and each of them can contain 3 people, but I remember Zenan preferred to have 2 people in her both projects. Here it's still 3 allowed, yeah, but if you just read her description, the work is better to be done by 2, yeah, that's what you wish.
I can,
Oh, you also have a project with better 2 people,
I
right?
can change the limit, the number
Yeah,
limit.
I see.
to-
Exactly.
um,
Okay,
Yeah.
can be 2, can be
Yeah.
3, but not 1.
Yeah.
right? Yeah, so, because the workload will be a little bit different. Because there's certain flexibility in some topics, not all, to do this 2 to 3 options. But still, there could be a case that the one project is only chosen by 1 student. Most difficult one, only 1 student chose it. That's possible. Last year we had such a case, because we don't want to force the group. We want to really let you to do the group forming and topic choosing. You can have lots of strategies. Invite your friend, invite your colleagues to choose one topic together. If you find one you really want to choose, but it's taken, and talk to the guy or girl, and you can swap. Treat her or him a nice dinner, and then he or she is willing to swap with you and so on. So basically, the principle is first get, first serve. Yeah, but the unlucky case is if there's only 1 student choosing 1 topic, we will most likely cancel that topic, and that student will have to be merged to another topic. So I really hope that doesn't happen again, because it's a little bit difficult for the students. Okay, one option is not taken, but so we cannot really make 1 person project. Yeah. Good. I hope it's clear. So is it clear online as well?
Yeah, yes.
So you can always change. If you can choose now, kind of reserve, but you can still change. Do we have a timeline? Okay.
Yeah, it will start at 10 minutes after.
Yeah, I think we should probably give that information on the slides later. Yeah.
Yeah, it starts from today after this lecture, and
Exactly.
we'll keep during 1 week.
For 1 week.
Yeah,
Yeah,
for 1
the
week.
deadline is next
It's,
Monday,
11th.
11th,
Yeah.
September 11th. Okay. September 11th is Sunday, isn't it?
Sunday. Oh, yeah.
Yeah.
So Monday.
All right, so now you know the valid time. As I said, so manage strategies to be formed. Find someone you like, find topic you like, or find both you like, and then you can just choose one. So within this time, feel free to talk to your other advisors to get more details. Yeah. Email them, or team meeting, online meeting, physical meeting, all possible. Yeah. Good. We'll put this deadline in the slides later on and upload it. I think it's written on my courses. You can get all this information just to make it easier for you to see the deadlines for the choosing group forming phase. All right, so I think that's clear, isn't it? Everybody? None? Are you clear? Okay, excellent. So these guys are having some strategies already. Yeah. Good. I think that's the group forming stuff. And yeah, here's about workload, some conventional things. So kickoff lecture, 2 hours. Midterm workshop, 4 hours. Group project, 58 hours of report.
this is about report writing. I mean, this is an estimation. So we don't suggest you write 100-hour report. Yeah, so it's something about 50 to 60 is good enough. Yeah. And I will show you the evaluation criterion. So it's not like a thesis just evaluated based on the report. So we're really evaluating the performance, the hands-on performance. And final workshop 4 hours, and a seminar 1 and 2 hours together, and group project work 200 hours per person. And the total, you will have 270 hours invested to this course per person. Yeah, so it's a 10 credit course, and running from period 1 to 2. And so here's the group workload. So it's 270 hours times the number of the students. So we'll be evaluating towards that. So otherwise it will be unfair for people working in 3 people group or 2 people group. Yeah. Good. So you see, it's a lot of commitment. If you have a through group, a 3-member group, we're going towards to around about 900 working hours. That's a lot. Yeah. That's like 1 year study for all of you. So it's very condensed and interesting stuff. All right. Finally, the most important thing, the course grading. Everybody is interested in that. So this is the so-called daily performance, 15 points. The daily is really just the daily. So this will be given by your advisors, because I think everybody, they have their own mechanisms. But the common thing is that they will organize meetings with you once or twice per week to just meet you group and check up your progress. You can ask questions to them. You can report your progress and what difficulties you met, what excellent progress you have made, and everything like that. Yeah, so this will be really considered in the so-called daily performance. Yeah. So taking 15 points, yeah, and then it's the midterm review meeting, 10 points. Yeah, so it's the first workshop we mentioned, happening around about October, end of October. So over there, they're just checking your general progress. You're getting into the topic. You're actively just moving forward. Yeah. It will be not too much content-wise, so that's why you see the points are not that big. But we want to see your progress over there. And attending seminars, 5 points as well. Yeah, easy points for you to get. So just to see something in your account. Yeah, because otherwise you will see nothing. All this daily performance and final report will be really given towards the end. So midterm reports, the points will be given early, and attending seminar, if you attend one, you will get 5 points. Yeah. Yeah, good. And then the final seminar, final report, 50 points. Yeah, that's the kind of indicator of your performance. But as I said, it's not going to be as strict as a thesis. You can be really creative over there, and also don't feel really stressful by writing this. As I said, you can write really valuable stuff to describe your discovery, your product. I don't need to read 20 literatures, write a heavy state of the art. Yeah, good. And final seminar, 20 points. And sorry, this is the so-called final workshop. Yeah, it's a little bit misleading. So this is the final workshop. You will just compete for the best team award and also show off your achievements in this 3 months. All right, some optional deliverables, 15 points. So this is something designed for your creativity. Yeah, We don't have a strict rules about this. Yeah, one example I could give is some really nice, let's say, well-organized code can be a deliverables. For example, the group 1 last year developed a really nice code about genetic algorithm. They published it on GitHub. I don't know if they got many attractions and so on. But that could be a nice deliverable for you to get additional points. Yeah. So the final kind of output will be not just report and also the seminar presentation. It could be also a computational product. Yeah, it could be anything indeed. If you really use this to make a nice software and you want to make a startup about it, that's definitely 15 points. Yeah. So anything possible over there. I think in total, if you sum up, I don't know if anyone summed up, we're talking about 115 points, are we? Yes. Exactly. And how to convert it to 0 to 5? You see, 5 is requiring something beyond the 90. Yeah, so we're really generous here, actually. So the maximum is 115, and the 90 is already good. Yeah, and 90 is already good. And 4 to 5 is between 80 and 90, and 70 to 80 is 3 to 4, and 60 to 70 is 2 to 3, and 50 to 60 is 1 to 2. Yeah, I think it's probably quite generous, because that's also the way I would like to motivate you. So here for this course, we're really pushing you for excellence. If you want to just say, okay, I want to pass, I don't want to make hard life for myself, I don't want to motivate myself, it'll be a little bit difficult for your teammate, but to pass is not difficult task, I would say. Instead, I would really like to kind of motivate all of you to go for the 5th grade, because that's not hard to achieve. Yeah, you can see from the grading system, and it's also fun. Yeah, of course, for guys who have good GPAs, go for that. I don't even need to say anything about it. But for people who didn't get a very excellent dream GPA yet, this is the best way for you to get there, because the course is 10 credits, and I would really motivate you to get your talent in this course, because this is most likely your final compulsory course, and you can really make a very good signature for your bachelor study. All right. I think that's all. Are we on time? Excellent. Yeah, perfect on time. Do you have any questions? Yes.
About the report, how many pages, like, is there a minimum, maximum?
Well, we said minimum is 20 per person.
Okay.
Yeah, so if you have 2 member group, it's gonna be 40. This is minimum. Maximum, you can go a little bit lengthy, but don't go too lengthy. Yeah. And if you have 3 people group, it will be 60. Yeah. No further questions.
It's more about the deliverables, additional 15 points.
Oh, additional 15 points. Yeah, that's just something for you to attach to the whole project in a more systematic way. So I can imagine you would develop a code here, code there, and doing this, doing that. Yeah. So in the end, it's probably a mass stuff, but you solve the problem. So you get the results and that work. But you left everything in a very messy way. Yeah. So if you could just organize this stuff into a very nice package, publishable. So you can put it into your GitHub, put it into your LinkedIn, your personal website. Everything's okay. Our research is completely public. Yeah, so, but I want something, let's say, usable, yeah, and transferable. So people would benefit from what you have developed. That is qualified as a, let's say, additional deliverable, yeah. And then you can get this 15 points in addition. Yeah.
Anything where other people also benefit from your.
Yeah, exactly. Exactly. So other people could benefit, and you also somewhat benefit from this development. Yeah. Good. I think that's all. I think I reserved a few tips for you, but I will go down really quickly. So this is tip number 1. Yeah. You know this figure, right? This is the iceberg. Yeah. The tip of it, and this is the concrete part of it. So this is reflecting what you're really reviewing for the engineering problem. So when you look at it from far distance, what you see is only here. Yeah. So if you want to really become an expert, if you really try to solve this problem, you have to really go deep and see layer by layer to get the full picture. So that's the point I would encourage you to really go deep, get hands-on to do stuff. Don't stay on the surface only. Yeah. The second is this so-called, oh, I forgot the name of it, but I think everybody knows this diagram. I usually talk to this to every PhD student I recruit. So the x-axis is your wisdom. Yeah, you go from know nothing to become expert, a guru. Yeah, and the y-axis is your confidence. I would say also all the similar things you could imagine. So I would say for most of you, yeah, not just your stage, but also the level you're touching now. You are somewhat here, maybe here a little bit, but you will quickly, yeah, go to this point, or probably you're already at this point. Yeah? So this is the so-called peak of mountain stupid. Yeah, because this usually happens to many people. Because after you just look at the iceberg at the far distance to a little bit close, you think, okay, I get it. I know everything. But when you really go further and further, you will quickly go to this so-called valley of despair. Yeah, this is a curve everybody has to go through. No one could escape it from it. So what you need to know is if you're at this point, no problem. You could expect you will go through such a point. Be prepared. If you're at this point, no worries at all, because after that, you will really pick up and go to the so-called slope of alignment, and then finally you get this plateau of sustainability. So you really realize what it's about, and you know what you know and what you should keep going. So you're just going and going. So the thing I want you to avoid is really when you reach this point and you think, oh man, I'm not this type of material. I will do something else. I gave up. Yeah, that's the wrong attitude. You could probably get something small out of this, but if you always go with such a attitude or such a kind of mindset, you probably could fail in many big issues. Yeah, so try to stick there and let yourself know you're very good and you will definitely go up with this curve. And the last thing is to give you the confidence. Why you think you could be the way to go up to get the plateau? This is the so-called 10,000 hour rules. Yeah, maybe you know it, some of you. Yeah, so study tells us you need only 10,000 hours to become an expert, become master of anything you would like to do. You want to become a mechanical engineer, you want to become a material scientist, you want to become a software engineer. You need to invest 10,000 hours to improve yourself, to do purpose training, not just general. I watched television 10,000 hours. I didn't become an actress, a famous actor. Yeah, you have to do purpose training. It will be painful, but you will gain really substantial stuff. So this course is a way to give you this stuff. But as you see, you have roughly 270 hours. But you are still at the very beginning. So 10,000 hours is roundabout. If you just calculate this way, 8 hours per day, 5 days per week, 44 weeks per year, it's equal to 5.5 years. Yeah, it's roughly similar to master plus bachelor. If you count a little bit later, it's similar to bachelor, master plus PhD. Yeah, so that's the timeline we're talking about. Yeah, but you can really shorten this. If you know what you want to become, you can already dedicate your hours and get started right now. And you will really becoming this expert within 5.5 years, or even within shorter time if you invest a little bit more of your life into this. All right, I think that's all, everybody. My final tip is there. And if you have any questions online, also here everybody is happy. And please ask, otherwise that's all about it. Good. Ready for the project course? Good. All right, I will stop recording and you will have everything online later on. Ping and the K. We're done here.
Oh, okay.
Yeah. So if you have questions, let me know. Otherwise, we will see each other
Yeah.
at the webinar.
Okay, thank you, Professor. I will sign up for the topic. Thank you.
All right, great.